2, it says find the equations of the tangent lines to the curve y equals 4 with the square root of x at points 4, 2, and 9 4/3. So they want two tangent lines. They want tangent line number 1 to go through the point 4, 2. They want tangent line number 2 to go through the point 9, 4/3. Both of these points rely on this curve. Try substituting x with 4. The square root of 4 is 2. 4 divided by 2 is 2. Y equals 2. That point lies on the curve 4 over the square root of x. If we try substituting x with 9, the square root of 9 is 3. 4 over 3 is 4/3. Y is 4/3. So basically those are two different points on this curve. This curve itself, x does not allow to equal 0 or negative numbers. So basically this graph would be starting at 0. It's going to have a vertical asymptote. The graph actually is going to go straight, pretty much straight up at 0. And then it's going to kind of flatten out as you go off to the side. All right. You don't have to see the graph to be able to do it, but just again, that's what's going on here. Both of these points exist on the graph, and we're trying to find the equations of the tangent line. So basically, two different problems. What I told you on Friday is we have our formula. Did you guys prefer the delta x version or the h version?
H.
H. Most people do. So let's go with the h version of the formula. It tells me the slope of any line equals the limit as h approaches 0 of f of x plus h minus f of x all over h. That's the slope formula for any line or any curve out there. As we know, a linear slope is just whatever number in front of x. A curvy slope changes for each point. So where the curve is, like let's say the curve is doing something like this, and then it goes really steep like that. This slope is positive, that slope is negative, and so on. So slope changes on curves, so we had to create a formula for slope, and that right there is the formula. And what hopefully you got out of Friday, if nothing else, was f of x is given to you. F of x is the function. H is given to you. It's 0. F of x plus h is not given to you. We have to create that. All right? So our first job, I don't even care what these points are to begin with. My first job is to use this definition of a derivative in order to find the derivative of this. Okay, I'm calling it a derivative. We'll get into the actual word derivative in chapter 3. But this is the definition of a derivative. Derivative is slope. All right? So we're going to find the slope formula for this function using this definition. So all I need to do is create f of x plus h. In this case, f of x plus h is going to be 4 over the square root of x plus h. I would also want to simplify that as much as possible. I can't. Okay, I can't make that any prettier than 4 over the square root of x plus h, so that is what it is. That's too many times, but that thing didn't report. I just wanted to check. Okay, all right. So, looking at this structure here, if I go with my slope formula here, slope equals limit as h is approaching 0, f of x plus h goes right here. So I'm going to put 4 over the square root of x plus h. I'm supposed to subtract from that f of x. F of x is the function, 4 over the square root of x. And what goes on the bottom is h.
You put h instead of x squared.
Oh, thank you, Chris. Yeah, x, not h there, sorry. All right. So, f of x plus h is 4 over the square root of x plus h. F of x is 4 over the square root of x, and all that goes over h on the bottom, as you can see. Now, I cannot substitute 0 into that expression, because if I try to substitute in 0, I'm going to get 4 over the square root of x minus 4 over the square root of x, which is 0, over 0, which is indeterminate, which means some algebra is probably possible to make this into a nice expression that can be evaluated. The issue, the problem, is the h on the bottom. If I can make the h on the bottom go away, all will be fine. I can put 0 in and all will work. So, this structure here happens quite often. Anytime you get a rational function, a number divided by something about x, you get this rational function, you're going to get kind of like this structure going on. This one has the radical feature in it too, which we might have to fix that also. But let's fix the rational issue first. If I multiply both the top and the bottom by the square root of x plus h times the square root of x, That's going to get rid of the fractions. It may or may not fix the entire issue, but at least it'll get rid of the fractions. So, if I do that multiplication, I'm going to get 4 over the square root of x plus h times all this creates 4 times the square root of x. 4 over the square root of x times all this, the square roots of x cancel out, so I get minus 4 times the square root of x plus h. And all that goes over h times the square root of x plus h times the square root of x. Limit as h approaches 0. It made it a little uglier in my opinion, but at least we don't have the fractions inside the fractions, so the structure is actually a little simpler, even though it doesn't look as nice maybe as it would. Got a lot more radicals in it now. Okay, I'm going to keep this h segregated. I'm going to keep it out all the time because I want that h to disappear. Ideally, I end up with just a bunch of h's on top. All those cancel, so that'd be great. In this case, I can't do anything to make this any simpler. These can't subtract because the radicals don't match up. Okay, at this point, I'm stuck, I can't do anything else. Now when you get radicals in a structure like this, the fix is rationalizing the radical structures. So what I want to do is I want the top to be no radicals. Okay, I want the top to be as simple as possible. I want no radicals on top. And this is just a little trick we did in Algebra 1 and Algebra 2. You multiply by a conjugate. The conjugate just requires you to take the exact same two objects in a binomial structure and change the sign to its opposite. And what that does for us is if I multiply this times this, that's just a difference of square structure. So I just square the first object, that's going to be 16x. Minus, and I square the second object, it's going to be 16 times x plus h. Now be careful, this is quite often a binomial or more than that underneath the radical. So make sure that when you get square root of x plus h times the square root of x plus h makes x plus h, that x plus h is in parentheses. On the bottom, I'm going to leave it just that big mess. Because again, h is outside of here. I don't see any benefit of taking both of these through here. It'll make some things a little nicer looking, some things a little uglier. So I'm just going to keep it all like that. The bottom, simplifying the bottom doesn't really help ever. So I just usually keep the bottom as is. Everything I keep multiplying by just keeps on increasing the size of the bottom. Okay, at this point, okay, so anytime you get radicals in one of these problems, that's what you have to do. Anytime you get rational structures, that's what you have to do. If you have both, rational structures fixed first, radicals second. Okay, once you fix both things, now looking at the top, I got 16x minus 16x and minus 16h, right? Everybody see that okay? So I'm at the limit as h approaches 0. If I simplify the top as much as possible, 16x minus 16x is 0. Minus 16h just leaves negative 16h on top. On the bottom, I've still got my h times the square root of x plus h times the square root of x times the square root of, or 4 times the square root of x plus 4 times the square root of x plus h. This is a term made up of the two things being multiplied together, negative 16 and h being multiplied together. H is being multiplied by x plus square root of x plus h, being multiplied by the square root of x, being multiplied by all this stuff. Okay, going back to Algebra 1, factors and reducing fractions. Okay, if two fractions have common factors on the numerator and denominator, you can cancel the factors that are common. This h is a common factor with that h, so they cancel each other. If you start adding and subtracting, each different piece has to be containing the object we want to cancel. This is a single object on top. Even though it's a bunch of stuff, it's one product. This times this times this times all that, right? There's a sum, but that's a factor. It's a multiplication piece. So that multiplication piece cancel. H has disappeared. So finally, if I put 0 in, I'm no longer going to get 0 on the bottom. I'm going to get this big mess on the bottom. At least it's not 0. So, if I substitute my 0 in now on top, if I substitute in 0, what do I get?
-16.
Negative 16, very good. There's a number on top. Substituting 0 has no effect on that number, it's going to be that number. The square root of x plus 0 is going to be the square root of x. The square root of x is going to be the square root of x. 4 times the square root of x is going to be 4 times the square root of x. And 4 times the square root of x plus h is going to be 4 times the square root of x. Finishing this out, I get negative 16 on top. I get x times 8 times the square root of x. Square root of x times itself is x, right? 4 square root of x plus 4 square root of x is 8 square root of x. Hello? No. They said he's a chiropractor. All right. Okay. Yep, thanks. Bye. All right. So negative 16 over x times 8 times the square root of x. This 16 and this 8 can reduce, right? So I end up with negative 2 over x to the 3/2 power. Or x squared of x if you wish. That's x to the half. You add the powers, you get 3/2. That is the slope formula for this specific curve. That's probably as challenging a problem as you're going to get at this point. Until tomorrow. No, I'm sorry, until Wednesday. Wednesday probably more challenging. But anyway, until Wednesday, this will be the most challenging thing you have to see. It involves all that algebra that I was preaching about for 2 years about how you need to really pay attention to detail and really get in control of all this stuff, because when they get to calculus, they get really, really ugly. Merry Christmas, here they are. All right, so they get ugly. Take your time, pay close attention to detail as you go through the process. You'll get faster at this, and there are shortcuts. We'll learn shortcuts. There's an easier way to get from here to here without all this stuff in the middle, but I don't want to show you that till you mastered this technique. All right? Now, this is my slope formula, negative 2 over x to the 3/2 power. So if I just consider all this stuff here is important, that'd be awesome. We could write that small. Let's go back to regular size here. Actually, too small. All right. All that work was to get this. There's my slope formula. Now, I've got 2 problems here. Problem 1, my point of tangency is 4, 2. I need to know what the slope is. I want to find the equation of the tangent line. So, the slope formula tells me slope equals negative 2 over x to the 3/2 power. So the slope equals negative 2 over 4 to the 3/2 power. Where did I get the 4 from? My point of tangency, x equals 4. All right, so whatever point of tangency is there, the x coordinate from that point of tangency is what you're going to substitute into your slope formula to determine the slope. Hopefully we all know 4 to the 3/2 power equals 8. You take the square root of 4, which is 2, and take that to the 3rd power, which is 8. 2, 2, 2. All right, that's what a fractional power does for us. So the slope here is just negative 1/4. So I've got a point of tangency, I've got a slope, and I've got my y equals mx plus b. I know this structure is legal because it says tangent lines. Lines have y equals mx plus b always, no matter what class you're in. That's what a line looks like. So y2 equals m negative 1/4 times x4 plus b. y2 m negative 1/4 x4 plus b. Substitute the 3 values in that we know. That gets me 2 equals negative 1 plus b, so therefore b is equal to 3. So one tangent line, the one that goes through 4, 2, is going to be y equals negative 1/4 x plus 3. The second tangent line, same idea. We got the different point of tangency here. We got 9, 4/3. So I know my point of tangency is 9, 4/3. I need to know what my slope is. My slope is equal to negative 2 over x to the 3/2, so negative 2 over 9 to the 3/2, very good. Again, whatever x is establishes what I put into my slope formula. 9 to the 3/2 power, we take the square root of 9, which is 3. 3 times 3 times 3 is 27. So negative 2/27 will be the slope of that line. Once again, y equals mx plus b is the structure of any line. We're trying to find the tangent line, so we substitute our y, m, and x into this equation. Y is 4/3 equals m negative 2/27 times 9 plus b. That's 4/3 is equal to negative 2/3 plus b. Whole number reduces 27 on the bottom down to a 3. Move the 2/3 to the other side, becomes positive 2/3. 2/3 and 4/3 make 6/3, better known as 2. So we get y equals negative 2/27 x plus 2. There's my other tangent line. Just real quick, I wanted to graph both of these against that, just to verify they actually look tangent. Take a moment for the calculator to open, I hope it opens. As part of the video, I probably want to get some elevator music playing waiting for this. Forever. I'll push the button. Ah, there it goes, okay. It's about to give up. There we go. So if we graph y equals 4 times the square root of x, or 4 divided by the square root of x, and let's make that a different color. There, we'll make that red. Okay. We'll make this one blue. And we'll make this one purple. Magenta, there we go. Matches our colors there. Okay, so 4 over the square root of, or 4 divided by the square root of x is the original problem. And the first line of tangency we got was negative 1/4 x plus 3, negative x over 4 plus 3. And the last one is negative 2/27 x plus 2, so negative 2x divided by 27 plus 2. And hit graph, well, let's set a window that fits this. So let's go from 0 to, let's go 12. Should be good enough to get 4 and 9 in there pretty well. And let's go y min 0, y max, you know, these y-intercepts are higher.
5,000.
Let's go y max of about, well, the numbers here aren't very large, so let's go up to about 5. Hit graph, see what happens. There's our original graph, 4 over the square root of x. Our blue graph should be our tangent through 4, 2, which looks very tangent to me. The magenta graph should be going through 9, 4/3 and look tangent. And it sort of does. It's kind of hard to tell. It's tangent here at 9, 3. We might even need to go a little further over here to see that one. Let's go up to 20 like it was originally. There's our original graph. 1, 2, 3, wait, it was going by 2s, 2, 4, 6, 8, 10, 12, 14, 16, yeah. 4, 2 is right there. 2, 4, 6, 8, 9, 4/3 is there. Both of them look really tangent to me, so that verifies that our answers are correct. Hopefully you saw that once we got through the algebra in the problem, okay, and that's what makes calculus difficult is the algebra, because a lot of people back in algebra 1 and 2 don't go through all that detail like they're supposed to, and stuff like this looks really challenging and hard to do. All right, but once you get through the algebra to simplify the expression, and once you get the slope formula, everything else is simple. Point of tangency, substitute in an x value to get the slope, y equals mx plus b. This is an algebra 1 level problem here. All right? These problems aren't difficult once you know this. The calculus is right here. That's where the difficulty lies. That's where you need to pay close attention and take your time. Okay. This part over here, you should be able to breeze through pretty quickly once you get the right slope formula.